Dear students, today we will be solving some problems related to the chapter mechanical properties of fluids. Okay, so till now whatever topics we have discussed, we will be solving some simple problems based on that. The first one, or actually the third one of this chapter, the problem is a cylinder of area of cross section 0.9 into 10 to the power minus 4 meter square with outlet of area of cross section 18 into 10 to the power minus 6 meter square. If the speed of the motion of the piston is 1.8 into 10 to the power minus 2 meter per second, calculate the speed of the outgoing liquid. So question is very simple. You have a piston, okay, we can consider over here. So this piston, we can take the area of cross section, that is equal to, what is the value given? 0.9 into 10 to the power minus 4 meter square, correct? So it has a small outlet, okay, over here with area, what is it? 18 into 10 to the power minus 6 meter square, okay. Now if the speed of the motion of the piston is, that is, we will take it as V1, that is equal to 1.8 into 10 to the power minus 2 meter per second, okay. Now you are asked to find out what is the speed with which the fluid will be flowing out, that is, we need to find out V2. So how to find out this? You people must have heard about the equation of continuity, correct? We know that one, right? What was equation of continuity? V into A is equal to constant. So we can make use of this idea. Now we can write, so you can take it as capital A, small a, no issue with that, okay. A1 V1, that is equal to A2 V2. A1 V1 is equal to A2 V2. Now what do you need? You need V2, right? So how to write for V2? V2 is equal to, take the term to the other side, A1 V1 divided by A2. So substitute A1 0.9 into 10 to the power minus 4 multiplied by, what is V1? 1.8 into 10 to the power minus 2 divided by, what is A2? A2 is 18 into 10 to the power minus 6. So what you can do here, you have numerator and denominator having 10 to the power 6, right? So you multiply these two, you will get a value, multiply that by 10 to the power minus 6, but we can cancel it on the denominator. So 18 10 to the power minus 6. Now these two will get cancelled. Here you have a value, okay, that you need to do by calculator. Now if you divide this value by 18, what you are going to get is nothing but 0.09 meter per second, or you can write it also 9 into 10 to the power minus 2 meter per second. So this is nothing but, okay. So what was V1? It was 1.8 into 10 to the power minus 2. Then V2 is 9 into 10 to the power minus 2. You need to understand that A1 is comparatively bigger than A2, correct alva? Nodi, A2 is in terms of 10 to the power minus 6. So you know when area decreases, velocity has to increase. So that's what we get there. So check the answer, try to do it by your calculator, okay. Okay, we will see the next problem. The problem is given like a fourth one. A 50 kg girl wearing high heel shoes balances on single heel. The heel is circular with diameter 1 centimeter, okay. What is the pressure exerted by the heel on the horizontal floor, okay. So you have a girl wearing a high heel shoes and she balances on one of her legs. Okay, now you have to find out what is the pressure exerted by the heel on the horizontal floor. So first what we will do is we will list out the things whatever given. Okay, given, we are given with the mass, correct? Mass is 50 kg. Now what is given? We are also given with the diameter. Okay, so diameter is nothing but 1 centimeter they have given. So this can be written as 1 into 10 to the power minus 2 meter, or it can also be okay, it can be written like this. Now what we are asked to find, we were asked to find the pressure. Okay, so how to find the pressure? Okay, let's write P, that is equal to force by area. It's known to us, right? Pressure is nothing but force by area, and you know that force is nothing but mg and area is nothing but pi r square. Correct alva? Force is mg and area is nothing but pi r square. Now we are given with the diameter. How to find out r? R is equal to d by 2. So what it will be? 0.5 into 10 to the power minus 2 meter. Okay. Now we will substitute for that. P is equal to m 50 into g, we will take 9.8 divided by pi is nothing but 3.14. Then what about this one? 0.05 into 10 to the power minus 2 whole square. Now you can do it by yourself. Okay, do the calculation and do by steps. Okay, then finally you will be arriving at an answer, that is 6.24 into 10 to the power 6, okay, Newton per meter square. So you will get this answer. Okay, then solve ಮಾಡಿ ಮಸ್ಟ್ಗೆ 50 into 9.8 calculator ಅಲ್ಲಿ ಮಾಡಿ ಮತ್ತೆ ಇದನ್ನು ಸ್ಕ್ವೇರ್ ಮಾಡಿ ಸಪರೇಟ್ ಮಾಡಿ. Here you will have 10 to the power minus 4, then it is like 1 by 4, so 0.25 will get. Okay, 0.25 because 525, right? So it will be 0.25. ಇದನ್ನು ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ. Okay, divide this, then take the power to the numerator. So you will get this answer, 6.24 into 10 to the power 6. Okay, the next problem, a hydraulic automobile lift is designed to lift cars with a maximum of 3000 kg. Area of cross section of the piston carrying the load is 425 centimeter square. What maximum pressure would smaller piston have to bear? So you are given with a hydraulic lift. Okay, so it has one smaller piston as well as another larger piston. So larger piston will be carrying the vehicles and smaller piston is a one which will be having exerted with the pressure, or the force will be exerted on this side. Here vehicle will be lifted. Correct, right? Okay. Now first what we need to find is the force exerted, or the force we'll write like this, the maximum force that the bigger piston can bear. Okay, so how do we write this? We can write the maximum mass, correct, or the weight 3000 into and acceleration due to gravity 9.8. So this will be the maximum force that the bigger piston can bear. Now what is the area of cross section? Area of cross section of bigger piston that is given, it is equal to 425 centimeter square. 425 centimeter square. Now we have to convert into meter square, so it will be 425 into 10 to the power minus 4 meter square. Now we will find out the pressure on bigger piston or the maximum pressure the bigger piston can bear. We'll find it out. How to find out? P is equal to F divided by A. So we can write F, what is the value? 3000 into 9.8 divided by area is given, right? 425 into 10 to the power minus 4. So do the calculation, you will be getting a value. Calculation nimastake ಮಾಡಿ ನೋಡಿ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ. 10 to the power 5, okay, Newton per meter square. Now you know from Pascal's law that whatever pressure exerted on the smaller piston will be equally distributed to the larger piston. Therefore we can understand that whatever pressure the larger piston can bear has to be equal to the pressure which the smaller piston can bear. ಅರ್ಥ ಆಗ್ತದಲ್ವಾ? ಯಾಕೆಂತ ಹೇಳಿದ್ರೆ ಎಷ್ಟು ಪ್ರೆಷರ್ ನಾವು ಸ್ಮಾಲರ್ ಪಿಸ್ಟನ್ ಅಲ್ಲಿ ಎಕ್ಸರ್ಟ್ ಮಾಡ್ತೇವೆ ಅಷ್ಟೇ ಪ್ರೆಷರ್ ಇಲ್ಲಿ ಬರೋದು. So you won't have anything extra to that. So whatever pressure the larger piston can bear, it will be equal to the pressure that the smaller piston can bear. So we can write the pressure smaller piston can bear is equal to the same value 6.95 into 10 to the power 5 Newton per meter square. Okay, so this is about the problems. We have solved 3 problems in today's class and we will be solving some more problems in the next class. Before that, I'll tell you a brief idea about the surface tension. Okay, so surface tension I'll be doing in the next class, but for the time being I'll be giving you a very clear, like a brief idea about the surface tension. Now you people must have seen this lotus leaves. When you put water into that, what actually happens? Water will float, right? Water will not stick to that. Similarly, if you take some mercury in a glass bowl and if you just try to do it like this, okay, try to move it, then what happens? It actually plays, like it will be playing on the bowl, right? It will not stick to any particular point. It will be moving here and there. Why actually that takes place? There are 2 types of forces what you need to understand. First one is cohesive forces, next one is adhesive forces. So before explaining the surface tension, I need to give you a brief idea about this cohesive and adhesive force. Surface tension we will see in the next class. Okay, so cohesive forces are the forces acted upon by the molecules of same substance. So if I take this chalk, the force between the chalk molecules is known to be the cohesive force. It is the force between substance of molecules of same substance. ಒಂದೇ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿರುವ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ನಾವೇನು ಹೇಳ್ತೇವೆ? ಕೊಹೆಸಿವ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಇಫ್ ಯು ಸಿ ದಿಸ್ water will be, if you just leave some water, it will be flowing, and you see that water, it actually flows like everything stuck together, right? It is not like half of the water is flowing here and half of the water is flowing here. They will be flowing together. That means there is a force between these molecules. Okay, so this force is known as cohesive force. Now similarly, adhesive force. If I take the super glue and if I stick, like if I apply over here and if I do like this, after some time I'll not be able to open this. My fingers will be stuck to each other, right? Why that actually happens? This super glue actually it builds a bond between the super glue and this finger, at the same time the super glue and this finger. Then they also have a bond between themselves. Now what actually happens? It will be stuck together. Otherwise, we can see this paint. When you apply paint on a wall, why it doesn't simply float? It's stuck to that, right? It sticks to the wall. That is because it is a force of attraction between the molecules of the wall and the paint. So like two substances, force of attraction between molecules of two substances, that is known as adhesive force. Okay, so these are the two things what you need to have some idea. In the next class we will see in detail idea about the surface tension. Okay.